Today we're talking about the probability of compound events. So we will start by talking about independent events. Independent events are events that do not influence one another. So for example, an event that wouldn't influence one another is if we have two dice. If we have two dice and we roll one dice and then we roll another. Does the result of one dice affect the result of the other? No, those are independent events. Okay? So when we're talking about the probability of two independent events, the formula would be the probability of A and B is equal to the probability of A times the probability of B. So let's remind ourselves what probability was from last week. Probability of an event is equal to the number of favorable outcomes over the number of possible outcomes. So let's say we're talking about these two dice. Two regular dice. How many sides does each dice have? 6. So if we want to find the probability of rolling a 3 and on the first dice rolling a 3 and rolling a 5 on the second dice. So if we roll the first dice, we rolled a 1. So what was the probability? Probability of a 3 and a 5. What's the probability of a 3? 1 over 6, because the dice only has one number 3. If I roll the next dice, what's the probability of me rolling a 5? So 1 over 6. So my probability of rolling a 3 and a 5 would be 1 over 6 times 1 over 6. That means 1 over 36. Let's say I want to find the probability of rolling an even on the first dice and a 4 on the second dice. So let's roll the first dice. The first dice rolled a 3. So what's the probability of an even on the first dice? 3 out of 6. What's the probability of rolling a 4?
1 out of 6.
1 out of 6. 3 times 1 is 3. 6 times 6 is 36. Can I simplify this?
Yes.
1 over 12. Yes. Yes, you can.
Miss Andres, do you leave it as a fraction or just...
As a fraction is fine. Okay. Let's say we have for another example. If we pretend we have the word algebra. And each letter is on a card. If we pretend we have these cards in a little baggie, and I say, what is the probability of a letter A replacing, keyword, replacing. So I pick one, I look at my card, I replace my card, and then picking a B. So how many A's?
2.
So 2 out of how many letters?
7.
So if I take one, I look at it, I put it back. What is my probability of a B? 1 out of 7. Why do I say keyword is replacing? So our total continues the same, right? That's why the keyword is replacing. Yes. So 2 times 1 is 2, and 7 times 7, 49. Let's say we have this same word, algebra. And I say, what is the probability of picking a vowel and L? How many vowels?
3.
So 3 out of 7. And what's the probability of an L? Did I say the key word? Okay, I forgot. So probability of a vowel replacing the card and then picking an L. So that means 1 out of 7. So 3 over 49.
So on the test it doesn't say the keyword.
The probability of two dependent events is the probability of A and then B. So the probability of A times the probability of B after A. Dependent events are events that influence each other. So for example, if I have this bag with 8 yellow beads and 10 pink beads, and I say, what is the probability of picking yellow, then pink, without replacing?
Just one yellow.
One yellow and one pink. So I put my hand in here and I pick one and I don't replace it. So picking the first one, picking the yellow one, I said we had 8 yellow and 10 pink. So if I pick one yellow means 1 out of the total of 18. But I don't replace it. I have it in my hand. So how many beads are in the bag now? 17. So what's my probability of pink? Why did I put 1? 8 out of 18 for yellow, and how many pink? 10 out of 17. So if I'm picking from this bag, look at the bag. It has 8 yellow and 10 pink. Put my hand in here, pick one at random, and I don't replace it. How many are left?
16.
17. 17. So why is the probability of yellow 8 out of 18? There's 8 yellow and there's a total of 18. But if I picked one out, my probability for pink changes. There's 10 possible pink, but now there's only 17 beads in the bag. Yes or no?
Yes.
So what do we get?
80 over
80 over 306. Can we simplify this? 40 over 153. Okay, so let's try dependent events with the word algebra again. We have the word algebra and each letter is on a card. So what's the probability of a vowel and then a G without replacing? So what's the probability of a vowel? 3 out of 7. If I've taken one, how many letters are left? 6. And what's the probability of a G? 1. So 3 out of 42.